Welcome back, and we want to tie in some physical applications of variation. So, Xavier, or Dr. Pratt Racina, provided these slides, and so you may have seen these before. We're just going to buzz through them and look at them from a mathematical lens, and specifically a lens that that's using variation. So, here we go. Coulomb's law, you might have discussed that energy, or electric potential energy, is equal to E and then K, or Q1, Q2 over R. And we're talking about charged particles here. So the idea is that you have one charge a certain distance from another charge, and then they're orbiting each other. But when we compute this, it's a number, and the units for energy is joules. And then again, so distance is never negative, so the only thing that we have to worry about in terms of whether this number is positive or negative is really the signs of the charges. If we have opposite sign charges, it's going to be a negative energy, versus if it's same sign charges, it'll always be a positive number. Now, in terms of variation, what type of variation? So let me back up. Q1 and Q2 we would know. Okay, and for our purposes, let's call the charges, and I'm going to say Qi is either plus or minus 1. So protons or electrons. Okay, and so just think of this as either a positive or negative 1 in the numerator. Don't care much about that. K is going to be a constant, right? And it's provided here. E and R are the two variables. So really this is saying energy is a function of R, or the radius, or the distance apart. Okay? But anyway, so what type of variation exists between E and R? Answer that in a quiz question. Okay, well, as you answered in the quiz question, it should be inverse variation. So again, as you increase one, the other decreases. Typically, that's going to be if you have same sign charges too. So if they're opposite sign charges, then it's actually a little bit trickier to figure out. It behaves more like direct variation. Sorry. So make sure to just note that it's inverse variation if you have same sign charges. Okay. We can also talk about electrical force. Same thing, or similar things. So this is a vector quantity, so we have to specify magnitude and direction, and the unit for force is newtons, all that good stuff. Okay, and I'll let you read that as you like. Okay, big thing here is I want to think about energy and distance. Okay, so we have two charges of same sign. Here we go, and here's another question that I want you to pause the video and think about. So if you have two charges of the same sign get closer, and again, you might have already discussed this in chemistry, what happens to their energy? Which one of these is it? So pause the video, try it out, and resume when you're ready. Well, I think I have to approach this from a mathematical perspective. So if I know they're the same sign charges, the graph looks something like this. Okay, so as they get farther apart, so they're repelling each other, right? That's the physical interpretation. So there's as you bring them closer, they want to repel, and so when we bring things closer, that to put them closer requires a lot more energy, right? Because they want to push each other apart. So if they get closer together, the energy should increase, and that's what we're seeing in the graph, and become more positive. So it is A. All right. So there we go. If we look at charges of the same sign, opposite sign, then the story changes a little bit, maybe. I don't know. Pause the video, try this one out. So again, as two charges of opposite sign get closer, what happens to their energy? Okay, now in this one, I have to do a little bit of thinking about this one. So this is E is K, and then if these are opposite sign charges, I can effectively think of this as like minus 1 over R. And so this is really just saying, at the end of the day, this is minus K over R, and R can't be negative, so what ends up happening is something like this. We get a graph like that. And so again, thinking algebraically with the equation, thinking graphically with the equation, and then thinking physically with, okay, if you're bringing opposite sign charged particles together, they're going to want to come together quite easily, and there's actually very little energy that you need to put in. So we define that energy to be negative. So as they get closer, their energy actually decreases and it becomes more negative, okay? Because it's becoming a larger negative number. That's what this means. Versus less positive. Well, we can, if it decreases, less positive would be the idea of it coming down here. It'd be going down like that. Okay. So there we go. Increases, decreases, and I'll also mention that this isn't necessarily the same idea of a function increasing or decreasing as well. Okay, so then here are a couple questions that I want you to answer in the quiz questions. So again, you have two charges of opposite sign particle, which one has the highest potential energy? And then we have, so different signs in the first one, same signs in the second one. You'll have two quiz questions to try out. Okay, and so then that is all we're going to look at now. Oops, let's go back here. And so in later videos, or in class, we'll have a few more exercises related to this. And so let's try and bring this idea of energy into our discussion with variation in class.